Hi there, this is Ms. Page. In this lesson, we're going to talk about how to find the surface area of prisms. So if you recall, prisms are solids or three-dimensional figures in which the sides are considered, or the sides must be rectangles, and then the bases may be rectangles as they are in a rectangular prism shown here. But they also might be other types of shapes. So in a cube, all of the sides are squares, which are special types of rectangles, so are the bases. But in a triangular prism, remember that the bases would be the triangles, and then the rectangles would be the general sides. And this is a different one too. This is a pentagonal prism. So the bases are the pentagons, and then the rectangles again would be the general sides of the prism. That's important because if we're going to use a formula to calculate surface area of a prism, which we're going to talk about in a moment, we have to understand what the bases would be for, because the bases are in a particular type of, or a particular place in the formula. All right, so here is the formula for surface area of a prism. And so if you're going to use the formula, you have to be able to remember it. So it's kind of different. It uses a lot of letters to represent things. So here we have S for surface area equals L plus 2B. And so what we have to understand is that L is what we call the lateral area, and that is the area of only the rectangles, the rectangular sides. And then the B, as we also used in our volume calculations and volume formulas, B is the base area, or the area of the base, and it's multiplied by 2 because prisms have two congruent bases. So that's the 2B part. So what is this L? Well, like I said, L is the area of the rectangular sides. So in the formula, we have multiple rectangular sides, but they may not all be the same size rectangle. So what we have to do, or one way that we can calculate all of the rectangle areas at once, is to actually find the perimeter of the base. That's this P. So the L part here is PH in this form, and the P is the perimeter of the base, whatever shape the base is. And that's like all of, say, the widths of all of the rectangles. And then the H is the prism's height, and that would be like all of the lengths of the rectangles. So remember, area of a rectangle is length times width. So the perimeter takes all of the widths, multiplies them times the lengths of all the rectangles, which would be the same as the height of the prism. Well, you might be thinking, oh man, that's complex. And if you're good at remembering formulas, then it can work very nicely for you. If you are not so good at remembering formulas, then it may not work so nice for you. So if you are, like I was saying, if you are comfortable with formulas, you're good at remembering them, then you can use the formula when you're finding the area of a prism. If it also works very nicely if you are finding the total surface area, is when formulas can be helpful, assuming you can remember it. However, if you're not good at remembering a formula, if you require remember, in an earlier lesson, we talked about nets of solids, where we unfold a solid, we lay all of its sides out flat, and we can also use a net to help us calculate surface area. We would calculate the area of each side or shape and then add them together. This is a good method if you are good with your basic area formulas, like you know how to find the area of a rectangle, a triangle, and a circle, pretty common shapes, but you can't remember formulas very easily. If the figure is unusual, like it's got weird, there may not be any formula for it, then a net is your go-to. And if you're finding the area of only some of the surface of the figure instead of the whole thing, a net might be easier than modifying a formula, which is another strategy in those cases. All right, let's take a look at a problem. All right, so here in this problem, we are going to find the amount of wrapping paper that's needed to wrap the box, not counting overlap. So like if the wrapping paper just meets edge to edge. It's basically like finding the surface area of the box. Now this box is a little unusually shaped. It is a triangular prism. So what we have to do is find the area or the surface area of a triangular prism. So it's a type of prism. So I'm going to do this problem in two ways. One is I'm going to use the formula, and second is I'm going to show you using a net. As far as your problems go in assignments and whatnot, it does not matter to me which method you use. All right, so first off, what we want to make sure is that we have all of the information that we're going to need in order to use the formula. So in order to use the formula, what we need is all the measurements of the base, because remember that we have to find the perimeter of the base, and then we need the height of the prism. So the bases, of course, would be the triangles, and they're right triangles. We can see the little right angle symbol in here. So notice that we actually don't have the measurements for all three sides of the triangle. We have our 3.6 inches here. 6 inches would be this side too. So we know that's 6 inches, but we don't know this third side. So we're going to have to find that first, otherwise we cannot find the perimeter of our base. So we'd have to recognize, okay, we've got ourselves a right triangle. We can find the third side of a right triangle when we know two sides by using our Pythagorean theorem. So that's where we start. So our Pythagorean theorem, remember, is a squared plus b squared equals c squared, where c is the measure of the hypotenuse of the triangle, which is the side that's across from the right angle. So here's our right angle, and going across, that would be our 6 inches. So we'd have our 3.6 squared plus the other leg squared would equal our hypotenuse squared. And now I would personally just use my algebra here and then use my calculator at the end. So I would subtract the 3.6 squared, and then I would take the square root. It's going to be the principal square root because I need a side of a triangle to be positive, so no plus minus in this case. Now I would use my calculator. I may or may not have to round. If I do have to round, I'm going to carry it out probably 3 places or so. Here, however, no rounding is necessary. We get 4.8. So that would be this side here, and it would also be in inches like the other two sides of the triangle. All right, so now what I'm going to do is calculate surface area. So I'm going to use my surface area formula here, like I said. So my surface area formula would be my lateral area plus the area of my two bases, where my lateral area is my rectangles. And the way I find the lateral area, the area of those rectangles, is I take the perimeter of the base and I multiply it times the height of the prism. All right, so the perimeter of my base is going to be, remember, the bases are the triangles. So my triangle is the base, so the perimeter of that's going to be the sum of the three sides, the 3.6 plus the 6 and the 4.8. Remember that the height of a prism always is the perpendicular measurement from base to base, and the bases are the triangles. So going from a corner of a triangle to the opposite corner of the other triangle, that measurement would have to be the height of the prism. So this will be times 8.5 inches. Notice that we're going to have inches times inches, which will be square inches. And square units are a unit of area, which is what we are calculating here. And then we're going to add that to 2 times the area of the base. Now, remember, the base shape is a triangle. So here you have to remember how to calculate the area of a triangle. Area of a triangle is 1/2 times the base edge times the height of the triangle. Remember, the base edge and the height of a triangle have to be perpendicular to each other, meaning they form a right angle. So that means that the 3.6 and the 4.8 are the base edge and the height. So we have our 2, which is part of our formula, times our 1/2, times the 3.6 inches times the 4.8 inches, and that's going to give us inches times inches, which is square inches plus square inches, so we're in square inches. All right, so now you can use your calculator all at once on this, which is what I recommend, but if you find it necessary, don't do any rounding, but you can do it in pieces and parts also. One thing to remember is that if you're going to use your calculator all at once, that order of operations requires our addition here be done first, and so we would want to make sure that the addition is in parentheses in our calculator. So put parentheses around your addition, times your 8.5, and then this is all multiplication over here, so no parentheses are required. In fact, you could even simplify this because 2 times a half is 1, so this could be simplified to just 3.6 times the 4.8 as well. All right, so hopefully if you're doing this calculation along with me, you are getting an answer that does not need to be rounded. And we have 139.68, and as I was talking about, we have square inches here. So now we would need to write, of course, our conclusion, and all of our problems here, we should write a conclusion that gives us the meaning and the context. I'm just clearing out some space here so I can write my conclusion. All right, so our conclusion, remember we were finding the total amount of wrapping paper needed to wrap the box that does not count any overlap. So the amount of wrapping paper needed is, remember there was no rounding in this problem, so this is an exact amount according to the calculations we were using. So is 139.68 square inches. And here I'm spelling out the square inches. If you wanted to use the power notation, that would be fine also. All right. As I earlier said, I also want to show you how to do this same problem using a net instead of the formula for those of you who don't like formulas or might have difficulty remembering them. So one of the things, remember, about our solid here, we have a triangular prism. So it has 3 rectangular sides and 2 right triangle bases. So in an earlier lesson, we actually drew the net. So this would be like the bottom rectangle. And then we'd have the one that's on the left, or you can look at the back side, the right, and then we have these 2 right triangles that are the bases. So what we would do if we're going to use a net is, some people, honestly, if you're going to use this method, you don't have to draw them connected, okay? You just have to know you have 3 rectangles, what the measurements of those rectangles are, and 2 right triangles, and what the measurements of those right triangles are that you need, and then how to calculate the area of those shapes. So going back up here, so our bottom rectangle would be 8.5 by 4.8. So we'd have that. So this is 8.5 times 4.8. The rectangle here would be 6 by 8.5. So that would be this one over here. So I have 6 times the 8.5 for that one, because again, area of a rectangle is length times width. And for this rectangle in the back, I have 3.6, and this measurement would be also 8.5. So that one on the left, what I've labeled the left, 3.6 times 8.5, would give me its area. So for my triangles, we actually have to also know, just like we did in the formula for surface area, the area of a triangle formula, because those are our bases. And so we have to understand that for those, we do 1/2 times base times height, and base times height are always perpendicular. So that would be our 3.6 and our 4.8. So for this triangle, we've got 1/2 times 3.6 times 4.8. And the same thing for this triangle. That would be its area. And then what you would do is you would find the areas of each of those individually. So starting with the rectangles and looking at this left rectangle, 3.6 times 8.5 would give us 30.6, and that would be square inches. All of these would be in square inches. The bottom rectangle, 8.5 times 4.8 would give us 40.8 square inches. The right rectangle would give us 51 square inches. And then the area of one triangle is 8.64, and we have two of those. And then we'd add all those together. Notice 1, 2, 3, 4, 5 numbers, 5 side areas, and it would give us exactly the same total, 139.68 square inches, and we'd come to the same conclusion. All right, we are going to end this video here, and I'm going to pick up in a part 2 where we're going to look at a couple of other examples.